Climate change implies to significant risks in forest fires, floods, and coastal storms. Scientists and environmental managers use GIS to study the environmental problems and how the environmental is responding to these natural and anthropic factors. In this course, we will use remote sensing techniques to solve these environmental problems. Current change and future scenarios consistently point to significant and increasing risks during becoming decades. Policies for sustainable development in Mediterranean countries needs to mitigate these risks and include adaptation options. Forest fires are a major hazard to Mediterranean forests, where on average of 500,000 hectares of forested areas are burned every year. It is for this reason that the assessment of fire risk lies at the heart of fire prevention policies in the Mediterranean region. Current fire management aims to control the fire regime by intervening on vegetation to foster more fire-resistant and more fire-resilient environments. New fire management strategies present a future potential to reduce the effects of global change and the extent and severity of fires. Understanding this link between landscape patterns and fire spread will facilitate the definition of landscape-level management rules, so that Mediterranean landscape become less fire-prone. In this exercise, we will calculate vegetation index. For this reason, we need some multispectral sensor. In this case, we will use this camera. It's a Parrot Sequoia camera that have 4 bands. One band for the red, another one for the green, and 2 bands to use the near-infrared. This sensor is very useful because we can calculate the amount of chlorophyll, we can calculate the state of vegetation, and we calculate a lot of vegetation index. The most famous is NDVI index. The study area covers the area of Les Gavarres Natural Protected Area in Girona. The Sequoia images are pre-processed by the semi-automatic classification plugin in QGIS. We'll analyze the color combination that allow obtaining the highlights of this study area. In the following image, we can see the representation of the image in natural color, product of the combination of the red band, green band, and blue. Also, the composition in false color represents the presence of vegetation better. In this case, we will use the near-infrared band, the red band, and the green band. The index more used in vegetation monitoring is the NDVI index, which is the ratio of the near-infrared and red reflectance of the electromagnetic spectrum. The NDVI index allows to generate an image that shows the relative biomass. This index takes advantage of the contrast of the characteristics of 2 bands of a multispectral raster dataset. The chlorophyll pigment absorbs more in red band and the high reflectivity of the plant material in the near-infrared band. Green vegetation reflects more energy in the near-infrared band than in the visible area. The estimation and relationship of the biomass of the study area with the normalized difference vegetation index was made by randomly selecting 23 points and using the point sampling tool complement, and we obtain the values of biomass and NDVI index for each selected point, where the following images was correlated and obtaining the result. In this case, the study area corresponds to fluvial mouth. Information on satellite images was downloaded from satellite Sentinel-2. The new Sentinel mission offers a combination of spectral and spatial resolution that is expected to provide significant new opportunities in floods modeling and mapping. With current technology and the availability of remote sensing tools through different servers, make it possible to determine or estimate the areas that are flooded or could be. The focus of this exercise, in which a methodology to determine flood zones, we will use another time the NDVI index and compare the results with the use of Sentinel-2 images. The green leaves usually presents a better reflection in the range of wavelengths near the infrared than in the range of visible wavelengths. On the other hand, clouds, water, and snow have a better reflection in the visible range than in the range of near-infrared wavelengths. The calculation of the NDVI creates a single band dataset that basically represents greenery. Negative values represents clouds, water, and snow, while values close to zero represent rocks and denuded lands. In conclusion, in this exercise, we will use remote sensing techniques to solve two environmental problems. The first one, we calculate the biomass and we relate biomass and NDVI index to decrease the risk of fire. And second one, we will use the same index, NDVI, to calculate the flood area.